Hi guys, we are Team HIT and we have been given this assignment for the hackathon, which is that we need to create a social media performance analysis. And we need to develop it using two distinct technologies, which is first one is DataStax Astra DB, which is a vector database, and next one is the Langflow for workflow creation. Now, what are the tasks we need to handle? The first one will be fetch engagement data, second will be analyze post performance, and then provide insights according to the data we have given it. And there are some sample outputs as well that what kind of responses they need. So now that we have understood the problem statement, let's dive into the implementation part. Okay. So this is a Langflow project where we have deployed a custom flow for the GPT to answer all our questions or for our custom LLM to answer our specific questions. So let's start understanding how we did it. First of all, we took a text input component where we entered the username, which is Sid in our case. If you want to change it to user, we can also do that. We just need to enter it. So now here you can see it's user. After that, what we have did is we took a chat input component and gave it the reference of this user, which is user in our case, and also the text which the user will ask to the GPT or the LLM we are creating. Next up is the prompt component, where we will provide three things. First one is the template, second is the context, which we'll be covering on the later part, and the third one, which is the question we have asked or the question which the user have asked. So let's go into the template section where we have wrote a basic prompt like you are an AI designed to analyze social media engagement data, all of that using DataStax and Langflow, and you will be given different kind of posts, and you need to be precise, concise, and give actionable points to the user. And we have set this two variables, which I mentioned. First one is the context, and second one is the question. Let's go back and let's see how we are giving the context to it. So what we did, first of all, we took a DB, which is Astra DB in our case, it's a vector database. We took it, we attached all the required tokens, which is Astra DB application token. We named the database which we have created from here. So you can go to Astra DB here. It's loading. Mhm. Yeah. So we here we have created our DB, which has some endpoint, some application token which we need to generate, and here is the functioning of it. Cool. Now we'll get back to our flow. Let's select it. Yeah, we are back in it. Here we have made and created a collection named Astra collection, which is under the DB called social media performance analysis. And it has two fields, majorly three fields, which we need to fill. First one is the search input, second is the ingest data, and third is the embedding model. For search input, what we took is the same text input, chat input, which we use here for the prompt. We matched it in the DB as well. Next is ingest data, for which we took a file, which is Langflow sample data. It's a Google sheet where we have described all the important data which we need to work around, which is social media analytics in our case. So we have different kind of posts with different usernames and their different post type, which is image, text, video, link, and so on. It has all the corresponding engagement, likes, shares, comments, matrix to it added. Also, it has matrix like did it get viral or not, all the trending hashtag it has, and all the sentiment score as well. So we have attached this to our flow and we have splitted the text into chunks using this component which is split text. So what's the chunk size? We have allotted to be 1000 and chunk overlap to be 200. Now the chunks are fed in this ingest data section, and now comes the important part, which is embedding, for which we have used OpenAI embedding. We have chosen the model, and the thing which is to be taken care of is the model of this DB should have the same model for this. So in this case, it's text embedding 3 small, and this also have that same embedding model. We have passed our API key here. Now what we are doing is we are getting a search result out of this Astra DB. We are feeding it to parse data component so as to get it as a text output. We will not be able to directly connect this search results with the prompt as a context. Rather, we have to go through this parse data, which will convert into text form, which we can then feed to the prompt component. Next up, when we have the prompt message, we need to feed it to a custom open API key. So we have this input, we have system message which you don't need. We need the model name for our case it's GPT-4 or mini, and then we have passed the API key of the same API. Cool. And lastly, we feed the output of that model, which is the OpenAI LLMs, to the chat output. Now, after creating all of this, we will get an API, which we can use in any external application of our choice. So we got an API using this command, and what we did was we created a repository, we created a code base where we created an Express server and then passed it as a proxy, and we created a proxy API. Because the problem was that we could not directly pass that API to the front end as it was giving us course error. So to overcome that course error problem, what we did is we created or we developed an proxy API, which is this. We hosted this on render.com and then we created our front end through React, simple React front end, and we deployed it on Vercel. And this is our finished product, the HITT Social, your one-stop destination for all the social media engagement problems. So let's try this chatbot. Let's try to ask him what are the different kind of posts which went viral and rank them in top three. So it's processing over the data which we have fed him, which is this Google Sheet, and it's getting me insight over that Google Sheet, which has different kind of posts in it. So here, it is also specifying all the steps it took for analyzing it. First one is filter viral post, then calculate average engagement matrix, then rank post types, analyze the viral post. So based on the average engagement matrix, we can rank the post types as follows. So first one is image, then it's video, and then link, insights. Top performing post type was image post, and then is video post, and then is link post. And then it also gives us the actionable recommendation. It says focus on image content to maximize engagement. Incorporate video, consider integrating more video content, and reassess link posts. Now, compare uh, videos and image posts and give me a conclusion in 3 lines. Let's get more specific. We don't want this much, we just want a three-liner answer for whatever we're asking. So let's see how it performs now. Yeah, so it gave us something. Based on the engagement matrix, video posts average 90 likes, 30 shares, and 28 comments, while image posts average 107.5 likes, 27.5 shares, and 23 comments. Image posts generally outperform video posts in likes and comments, indicating a stronger view performance for images. To optimize engagement, consider prioritizing image content over video in future posts. Wow, that's nice. Uh, let's give me insights based on percentage. Let's see. I hope we'll be getting some percentage out of this. Uh, mm, yeah, so we got it. Yeah. Image post high engagement with representing 45.83% of the total like across all posts type, and then 38.89% of total shares and 40.74% of the total shares. And likewise for videos, texts, and link posts as well. So yeah, this is our overall project. We're using DataStax and Langflow. We created a custom bot and then used its API as a proxy, and then created a proxy API and then fed it to a front end, which now we can use as a chatbot. Nice, right? So the team is HIT, and the people behind it is Ayush Arora, Atharv Atre, Siddharth Khandelwal, and myself, Shubh Jain. Thank you for listening.